This morning.
Yes.
I'm going to propose a question to you, and I just want you to answer it as truthfully as possible.
Okay.
I have here a tennis ball and a textbook, if you could feel. Okay. Now, which one is heavier?
The book.
The book is definitely heavier. Now,
Yes.
if we were to drop both of these, what would hit the floor first?
My first guess would be the book because it's heavier, but I actually think the tennis ball might hit it. Might hit the floor first.
Why?
I think the density of that, for some reason, would have something to do with hitting the floor first.
Gosh.
I would say the book.
All right, the book.
Yep.
Ready?
Because it's heavier.
Keep it.
The textbook.
Feel it. Just so you know, it's not a trick hacky sack. Okay. So the textbook and why?
It's heavier. Okay. The hacky sack is much smaller and lighter.
Okay.
Hello, ladies and gentlemen. Today's lesson is going to be brought to you by Galileo Galilei, a physicist from 1564 to 1642. Now, he is the father of modern thought. He said that all things fall at the same exact acceleration. Now, this is a thought that basically got into big trouble and put him on house arrest. But before we get into that, let's focus on that word acceleration right there. Okay, the word acceleration leads us to the word gravity. Because of gravity, things accelerate towards the earth. Okay, acceleration due to gravity. Gravity allows for us to basically walk on the earth and just move around and other good stuff. Now, gravity is a lot different for Earth as it is for the moon or on other planets. But we're going to focus on Earth for now. All right. So while I'm erasing this, please get out a piece of paper and write this number down. 9.8 meters per second squared. It's the acceleration due to gravity here on Earth. Okay, not anywhere else but Earth. This is how you write it. A sub g is equal to 9.8 meters per second squared, or g is equal to 9.8 meters per second squared. All right, now that that's out of the way, let's focus on this point right here. Let's go back to Italy, actually. All right, let's go back to Italy and revisit our good friend Galileo. Galileo, there's a legend behind the Leaning Tower of Pisa. Before it actually started to lean, Galileo would take really, really heavy objects, go to the roof and drop them. And then he would time it using a timer that he actually invented. He would get bigger objects and drop them from the top of the roof, and then he would get even bigger objects and drop it from the top of the roof. And legend says that because he would get such incredible weights, it started to make the tower lean. Okay, therefore we get the Leaning Tower of Pisa. That experiment led Galileo to think, wait a minute, all things fall at the same acceleration, because he would time the heavy objects and the lighter objects, and they would both hit the floor at the same exact time. And that was his voila moment. All right, let's do another experiment here. We have a man dropping a rock and dropping a piece of paper. If we drop them from the same height at the same exact time, we know that the paper will go back and forth, and eventually hit, and the rock will go right to the floor, okay? And therefore, the rock wins. But is there a way for the paper and the rock to hit the floor at the same time? Of course there is. All you have to do is crumble up the piece of paper, and you have to, well, get the rock and drop them at the same time from the same height, and then you'll find that it is a tie. They both hit the floor at the same time. Wait a minute. Oh, confusion. Didn't we just say that the paper would hit the floor at a slower time? Alright, now let's go back to Galileo's thought bubble. Galileo then said, wait a minute, it's vacuums. So if we have a chamber that is filled with air and we drop a feather, right, a red feather and a rock from the same height, the rock will hit the bottom of the chamber first, okay, because there's air, there's an atmosphere in there. But if we were to suck out the air using a vacuum and therefore creating a vacuum inside that chamber, remember, no air inside, no air resistance, the feather and the rock would hit the floor at the same exact time. That's what Galileo said. And it was very novel for that day and age because people thought heavier things fall at the same or faster than lighter objects. So we actually were able to conduct this experiment out in space when astronauts went to the moon. When Neil Armstrong and Buzz Aldrin went to the moon, they brought a hammer and a feather, okay? And the astronaut actually dropped them at the same exact time from the same exact height, and they found that both objects, the feather and the hammer, hit the surface of the moon at the same exact time. And the reason for that was, well, there was no air resistance. And the astronaut even said, well, would you look at that? Galileo was right. I'm paraphrasing, of course. Well, let's recap. Acceleration due to gravity is 9.8 meters per second squared, and all objects fall with the same acceleration if you are in a vacuum.
All right, so let's take a look. Same height, right? Right about? Yeah. Okay, now keep a close eye. Which one do you think hit first?
Same time.
Same time. One more time.
The same.
The same time. Did you see that?
To me, that looked pretty close.
Pretty close.
At the exact same time.
They will hit the floor at the exact same time.
Yes.
You want to test it out?
Sure.
All right. So ready? Eye level. What do you think?
Hit at the exact same time.
Exactly. Now, do you know why?
Because objects drop at negative 9.8 meters per second squared, always. That's how gravity works.
Good job, Mr. Turnick.
You got it.